what to do with this. I see a radical. I might think about using trig substitution, but it's not of the form a squared minus x squared, a squared plus x squared, or x squared minus a squared, is it? So since it's not of that form, I want to make it of that form. So that makes me think, complete the square. So you have to, I want to encourage or guide you of like, when do you know what to do? So I'm going to take it outside of the integral, outside of the radical even. I'm going to say negative x squared plus 8x. I know in order to complete the square, I must have a positive in front of the x squared. So I factor the negative out of those two terms. And then I'm going to complete the square. So I'm going to take half of this number. So I get an x squared, and carry along the minus x. And so I take half of this number and square it. So half of 8 is 4, and square it. So I get a 16. Okay, so I don't have an equation, so I have to keep this line the same. I didn't really add a 16. I really subtracted a 16. So now I have to add a 16. So this part here turns into x minus 4 squared, because that's the square I completed, plus 16. Now I'm going to put that back in here. And I'm always going to put this negative sign in the middle. So it's going to be the 16 minus x minus 4 quantity squared dx. I suggest an easy u substitution at this point. Just helpful to see the trig substitution. So this gives me 16 minus u squared du. Oh, will you look at that? That's sine, right? So u is equal to 4 sine theta. Du is 4 cosine theta d theta. All right, so here we go. So replacing with, get the 16 minus, and put the 4 sine theta in there. I get 16 sine squared theta. And remember, the most common mistake is to forget to put the du in. So don't do that. Don't make the common mistake. Keep that there. All right, let's see what happens here. So here, I can factor out the root 16 of the 4. 1 minus sine squared theta. And I carry along this 4 cosine theta. So these two 4s can come outside to be a 16. And then, oh, will you look at that? This gives me a square root of cosine squared. And I carry along this cosine. So I get 16. That's a cosine times a cosine. Cosine squared. Wow. What do I do with cosine squared? Oh, right. We get to use the half angle formula, right? So here, 1/2, 1 plus cosine of 2 theta d theta. So it gives me 8 theta plus 1/2 sine of 2 theta plus a c. All right, so I need to get back to x's, right? Okay, so let's see what my original substitution was. Okay, so I had this, put in black, this and this, right? So let's start with the u over 4 is sine of theta. So that means using the triangle opposite over hypotenuse. So this side here would be 16 minus u squared. And that's a happy moment, right? Because that's what it was the original problem. Oh, I can't get sine of 2 theta off the triangle. So that's where you need to know that identity. So sine of 2 theta is equal to 2 sine of theta cosine of theta. Okay, so let's redo that. So 8 theta plus, oh, look at that. If I put 2 sine theta cosine theta, the 1/2s cancel. So I get sine theta cosine theta plus a c. Okay, let's do it. So I get 8 theta. How am I going to get theta? I get theta from here. So if I take inverse sine of both sides, that gives me theta. So inverse sine of u over 4. And then sine of theta is u over 4. Cosine of theta is square root of 16 minus u squared over 4 plus a c. And then it's my last job to plug in what the u is equal to, and that was x minus 4. 8 inverse sine x minus 4 over 4. You always want to end your problem with the same letter that you began. Oops, 16 I meant to write that here. 16 minus x minus 4 squared over 4 plus a c. And it doesn't, the c could be multiplied by an 8, or it could just be left outside. Because c times 8 is just c. Weird thing.